Question number 2, you've got a square. A square is split into 4 triangles and each of those triangles are the same size. Your job is to work out the perimeter of the square based on the information that you know. So what you know is that the shaded triangle, which is the top one, has an area of 9 centimetres squared. So all the triangles are the same size. So if this one has an area of 9 centimetres squared, this one is also 9 centimetres squared. So is this one, and so is that one. Once you've got that information, you can work out the area of the whole square. So 9, 9, 9 and 9, which is the same as 9 times 4, which gives you 36 centimetres squared. So the whole square has an area of 36 centimetres squared. Now you know with a square that all of the sides are the same length. So to work out the perimeter, you need to work out what length each of the sides are. So you would have had to multiply to a number. So to work out the perimeter of the square, you need to look at what you know from the area. So the area is 36. So that means that each side must measure 6 centimetres because 6 times 6 gives you 36. So you've got 4 sides, each one measures 6 centimetres. To work out the perimeter then you're going to do 6 times 4, which is 24. So your answer to number 2 is 24 centimetres. Question number 3, you've got 5 fractions. Okay, so when you have to work out which is the smallest, the first thing you want to do is have a look at your denominator. Okay, so you're going to do something which is called the lowest common denominator. So you want to look for a denominator, the bottom number that you can change all the fractions into to make sure they all have the same denominator. Okay, so you've got 24, 8, 6, 4 and 3. So the number that I'm going to change them all into is out of 24. Make them all have the same denominator. So we don't need to worry about 17 out of 24. So we're going to start with 3/8. So we're going to put equals and we're going to make our denominator 24. So you have to think about what do you do to 8 to make it 24. So you times it by 3. Remember with your fractions, whatever you do to the bottom number, you must also do to the top number. So we need to multiply our 3 times 3, which gives us 9 out of 24. This is an equivalent fraction. 3/8 is exactly the same size as 9 out of 24. Okay, so we're going to do the same thing with this one, with 4/6. What do we do to 6 to make it 24? We times it by 4. We're going to do exactly the same thing to our top number. 4 times 4 is 16. Same with 3/4. We're going to make it out of 24. So 4 times what gives you 24? It's 6. Multiply your numerator by 6. Gives you 18 out of 24. And the same with your 1/3. 3 times 8 gives you 24. 1 times 8 would be 8. Okay, so you've now got your fractions all out of 24. So I'm going to write them out in order from the smallest up to the biggest. So we've got 8 out of 24. Then we've got a 9 out of 24. Then we've got 16 out of 24. Then 17 out of 24. And then 18 out of 24. So you can see that this one is your smallest fraction. Now in your answer, you need to write it the way it was given to you in the question. So the original fraction, which was 1/3. So your answer to number 3 is 1/3. 4, you've got a cuboid and it is 10 centimetres long, 5 centimetres wide and 7 centimetres high. So you have to work out the total length of all the edges of the cuboid. So for this one you have to imagine your 3D shapes, you have to know what they're made up of. Okay, so I'm going to add in this wee line, and this wee line here. Okay, so you've got 10 centimetres, so this is 10 centimetres, this is 10 centimetres, this is 10 centimetres, and this is 10 centimetres. So we've got 4 edges that measure 10 centimetres. So I'm going to do 10 times 4, which gives me 40. Okay, let's have a look at your 5 centimetres. So we've got 1, 2, 3, 4. Again, edges that are 5 centimetres, so we're going to do 5 times 4, which gives us 20. And then we've got 1, 2, 3, 4 edges that measure 7 centimetres. 7 times 4 gives us 28. So now what you've got to do is add those. So 40, 50, 60, 70, 80, that would give you 88 centimetres. Question number 5 then asks you to work out the area of the face with the largest area. So you're looking at the largest face, which is this one. Okay, so I would take it and draw it out separately. Okay, so you've got a rectangle. From here to here measures 10 centimetres, and then this edge here, the height is 7 centimetres. So for your area, you're going to multiply 10 by 7, which gives you an answer of 70. And with area, it's in centimetres squared. Question number 6, you've got someone called Isla, and her car's run out of petrol. Her petrol tank holds 40 litres of petrol, and it's £1.35 for every litre. So you need to know how much £1.35 times 40 is. So a much easier way to do this is to do £1.35, multiply that by 4 first of all. Okay, so you're going to use your formal method. Everything's lined up. Make sure you keep your tens, your decimal point, your tenths and your hundredths. Okay, so we're going to do 5 times 4, which is 20. 3 times 4, which is 12. Add your 2 gives you 14. So the 1 gets carried over into your tens column. 4 in your tenths. Decimal point doesn't move. 1 times 4 is 4, plus 1 is 5. Now that's not your answer because that's just £1.35 times 4. Because you wanted to times it by 40, what you've got to do with this answer is make it 10 times bigger. So we're going to do £5.40 times 10, which gives you an answer of £54 for question number 6. Question number 7, you've got a missing number divided by 7 equals 8.4. So we're going to use this fancy word again, which is called inverse operations, which just is a posh way to say the opposite. Okay, so the opposite of division is multiplication. So to work out this missing number, we're going to take 8.4 and we're going to multiply it by 7. Okay, so 4 times 7 is 28, decimal point. 8 times 7 is 56, plus 2 gives you 58. So your answer, your missing number, is 58.8. Question number 8, you've got a pie chart, okay, and it's showing some information about a P6 class and their favourite crisps. So there's 24 pupils all together. Okay, so each little part of the pie chart stands for a flavour of crisps. So you needed to label what each part stood for. So if you had a wee look, you're looking for this question at the size of the slices. Okay, so prawn cocktail's already done for you. It was 4. So salt and vinegar also had 4 people. So if you had a look at them, you could tell just by looking that this was exactly the same size as this. Okay, so your prawn cocktail was the same as your salt and vinegar. So that was your salt and vinegar. Ready salted only had 2, which was the smallest number of people. So you look for the smallest slice on your pie chart, and it was that one. So that one was ready salted. So you're left with smoky bacon and cheese and onion. Smoky bacon's larger. They have more people who chose smoky bacon than cheese and onion. So you're looking for the bigger slice of the pie chart, which is this one. And then that leaves you with your cheese and onion for that one. Question number 9, it's a map and a scale. So on the map, every 1 centimetre represents 7 kilometres. So 2 towns on the map are 7.4 centimetres apart. The question's asking you to work out what is the actual distance in kilometres. So what you're going to do is going to take the 7.4 centimetres and you're going to multiply that by 7. Okay, so a lot of multiplying decimals in this paper. Remember, you lay everything out and it's in the correct column. Okay, your decimal point doesn't move. Make sure it stays in the right place. And then you do your working out. So 4 times 7 is 28. Carry over your 2, write down your 8. 7 times 7 is 49, plus 2 equals 51. So your answer to number 9 is 51.8 kilometres. Question number 18. You've got 3 patterns, and in each pattern there are small triangles that are used to make bigger triangles. So if you have a wee look here, you've got the pattern number and the number of small triangles. So what the question was looking for you to do is recognise how these numbers are connected. So 1 squared is 1, 2 squared is 4, and 3 squared is 9. So the pattern number is squared to work out the number of small triangles. So how many small triangles will there be in pattern 7? So what you do to work that out is do 7 squared, and that's 7 times 7, which gives you an answer of 49. Question number 19, you've got a quadrilateral, which is a 4-sided shape. Okay, it's got 4 angles. You've been given the measurement of 3 of those angles, and you need to work out the size of angle A. So I'm just going to write them on. The shape isn't actually drawn to the size of the angles, so I'm just going to pop them in the ones. So 133, we'll call this one angle A. Okay, for this one we'll use 87, and for this one we'll use the 82 degrees. Okay, so this angle plus this angle and this angle and that angle all together total up to 360 degrees. Okay, it's important that you know that the angles in a quadrilateral, a 4-sided shape, equal 360 degrees. So 2 steps to work out the size of the missing angle. Step number 1 is to add the angles you already know. So I'm going to start with 133 plus 87. 7 plus 3 is 10, 8, 9, 10, 11, 12, and then 2, that gives me 220. I'm going to add on the 82 to the 220. That gives me a total of 302. So this missing angle is 360, take away 302, and that gives me an answer of 58 degrees. So angle A measures 58 degrees. So to work out the missing angle in a quadrilateral, you add the angles that you already know and take away the total from 360. Different from a triangle, because in a triangle the angles add up to 180, but in a quadrilateral they add up to 360. So it's the same steps, you just need to take away the total of the angles you already know from 360. Question number 20, you've got a statement with a missing number. You need to fill in the missing number. So 125 is what percent of 500? So what you had to think about here was your fractions and your percentages. 125, if you were to add 125 4 times, that would give you 500. So 125 is a quarter of 500. Convert that into a percentage and the answer is 25%. Question number 21, you've got a Venn diagram and Ellie's putting whole numbers from 1 to 20 into 3 different sets. She's got even numbers, multiples of 3 and factors of 24. So it says what number should Ellie put in the middle section? So that's this bit here. So it has to be an even number, it has to be a multiple of 3 and it has to be a factor of 24. So you've got 2 numbers that are going to go in there. They're even. They're multiples of 3 and they're also factors of 24. So I would think with your multiples of 3, okay, so you've got 3, it's not an even number. You have got 6, it is an even number, it's a multiple of 3, and also it's a factor of 24 because 24 divided by 6 is 4. So you're going to pop 6 in there. Okay, your next multiple of 3 is 9. 9 is not an even number. Then you've got 12. 12 is an even number. It is a multiple of 3 and it's a factor of 24 because 12 times 2 is 24. So that's your 2 numbers that go into the middle section of the Venn diagram.